possible.
It's unlikely.
But it's unlikely. And anyway, so it determines the cluster position, and then after these 5 cycles, if there is still a mixed signal, then it will be filtered out.
Yeah. Right.
Yeah. So yeah.
We just discussed that Illumina is, except of course Semgar, it's just one platform which has no problem with homopolymers.
Yes. So the reason for the homopolymers with for example Ion Torrent or the Roche platform, you always incorporate several. As for example, you have a stretch of 5 A's, and then it can incorporate all 5 A's in one cycle. So and then they distinguish the number of A's by intensity. So if you have 5 A's, the intensity should be higher than with 1 A. But the problem comes if you have a really longer stretch. So if it's maybe 12 A's, and then to distinguish between 12 and 13 is difficult. The Illumina system always incorporates only 1 in one cycle. So there you don't have this problem, yeah. So you don't need to measure the quantity of signal, you only need to detect the signal, and the signal should be pure. So these are the 2 colors. C for red for C, green for T, mixed for A, and black dark for G. And of course, when we developed and the platform, of course we cross-validated it with other platforms. Yeah? So we were running the same samples, same libraries on HiSeq, on MySeq, and on Nextseq, and we make sure that we get comparable data. So it really works in practice. Otherwise, the cluster amplification is the same principle. So this is how it works. You start with read 1, that's HP10 primer. Then comes the index HP12 for index 1, I7, and then you do you make the bridge and turnaround chemistry, and then you first start with index 2, and then you sequence read 2. So this is similar to sorry, that was the MySeq. Sorry, that was MySeq, and now the Nextseq is read 1, index 1. And then you do the turnaround. So you swap the orientation of the individual molecules in the cluster, and then you do index 2 and read 2. So
what's the difference?
So the difference is with the MySeq, you first do index 2 in the orientation number 1.
Okay.
And then you do the orientation swap, so the resynthesis of the cluster, and only afterwards you do read 2. And with the Nextseq, you do it after index 1 already, so one step before. Yes, so if you have dual index, you always need to do the turnaround chemistry. And here you can read both indices without the turnaround.
But Florian,
Yes.
everything of the chemistry are included, all the chemistry are included in the cartridge. So not necessary to order something.
No, they are all in the cartridge. You're correct. It's only important for the way you set up the run. Yeah. So if you do a single read, so only one read, but you want dual index, then you don't enter any cycles for read 2. So this is what you have to remember, right? So then it will stop here. And if you do paired ends, then it will do everything. So if you do only one index, you stop here. So read 1 and index 1. If you want to do dual index, you stop here. And if you want to do paired ends with dual, you do everything. And with a Nextseq, if you want to do a single read with 2 indices, you would stop here. The optics is more modular than on the Nextseq. So actually we started to make this concept already with the Nextseq, trying to with the genome analyzer and also with the HiSeq, we have many individual small parts. For the engineers, this means that if something breaks, they need all the small parts and to replace them individually. So it's a little bit more complicated, yeah. So of course, if you have an experienced engineer and if he has access to all the replacement parts, it's not a problem. But in the field, in the practice, our idea was with the Nextseq to have only a few modules, and then the engineer can quickly just exchange the whole module. So it should be faster to repair. That's the idea. So this is the optical module, and it contains 6 cameras. So they are in one piece. If one camera of the 6 is broken, still it can work. It gives data. You get still 5/6 parts of the data. Yes, so almost everything. Yeah, not the full capacity, but almost. So you can continue to work, but you can tell Interlabservis, and we will order a new part, a new optical unit, and then when it's there, we can just exchange it quickly. So that's the idea.
So sorry for to interrupt you. Will the machine inform customers that everything is broken, that one camera is broken and should be replaced?
Well, it will not send you an email, sorry, my camera is broken.
But maybe warning.
But you see it in the data, so you should see it very easily, that one section, so the image of the flow cell is 6 sections, and one section gives significantly worse data than all the other 5. It is. I can show you later what it looks like. So this is really easy to detect. So these are the 6 solid-state optic modules. I heard they are manufactured in Germany. So the instrument itself is manufactured in Singapore, but this unit is in Germany. So this is the fluidics. There we also changed some things in comparison to MySic. You see we have less tubing. Still we have tubing, and we have now an example that tubing is always bad because it can break, it can block. So the more tubing, the more fragile the whole system is. And we had a not very good experience with one system, the HiScan SQ. In Russia you don't have this system, and this is good. So in other countries, yeah, for example in Poland, they have several, and they are not so happy in general. Yeah, so some they work without problem, but many of them they give problems because they have extremely long tubing, and from this we learned that you have to minimize the tubing. And here this is what we did. So you can see these are the zippers that basically the capillaries that come from the top, and they go into your reagent cartridge. So they will pierce the aluminium foil that is covering your cartridge tubes, and there is no tubing virtually, yeah. So it's directly connected, and of course we have a little bit tubing here. So these are the valves. So the famous valve that with the old version in the MySic it was initially some problem, but now we have resolved it. Yeah, so now we have a good valve, and in the Nextseq we also used good valves. Yeah, and we have two of them. So yeah, so this is what I basically said now. Yeah, so it's also easier for the maintenance with less tubing. So you can imagine also the wash is easier, and there is less risk of contamination if you have less tubing. And another really advantage of the Nextseq is that it is self-cleaning. So automatically after each run it will clean itself. So when you start the run you have to pipette the wash solution into one position. I think it's here, and this is the bleach, the sodium hypochlorite. Did you manage to? You found it yesterday, right? Yes. So you always should make a fresh dilution of sodium hypochlorite. It should be between 0.03% and 0.06%. This is all in the manual. Did you? You printed. Okay, good. So please put it in some folder, so that and then it's really we should use it for the training later. Yeah. So we should really go through the manual step by step. And when you finish an experiment, always leave everything inside the machine. Yeah, so the flow cell and the cartridge should be left in the machine, and then before you start the next experiment, then you change it. Consumables. So you've seen already the cartridge. The flow cell, the cartridge, and this is the buffer cartridge. So in each kit you find these three components. Flow cell should always be stored in the fridge, so at 4 degrees. The reagent cartridge should be frozen, -20, and the buffer cartridge room temperature. And then you also have an accessory box frozen at -20. So four pieces. this accessory box has some, in addition, the index primer for the dual index and the hybridization buffer for denaturing the nitrate. It's the same like for nitric. So these are the kit sizes. We have 3 sizes, 75 cycles. So this is always total number, yeah. 150 cycles and 300 cycles. So this means paired end 150. And we always add additional cycles for the index. So we add 18 cycles. And so these were the sizes in terms of length of the reed, how many cycles. And then in addition, we have 2 different kit versions in terms of high output flow cell and mid output flow cell. Yeah? So small experiments, mid output, and there we have either 150 cycles or 300 cycles. And larger experiments, you have high output, and there you have the choice between all 3 lengths, 75, 150, and 300 cycles. For example, yes. How long? I have to go back to the table I had before. Here. The time. So, 1 time 75 cycles, 12 hours. So that would be, for example, you do, for RNA-seq you can choose. If you're only interested in levels of gene expression, it's usually enough if you do single run 75 cycles. If you want to see splice variants, and especially in transcripts, then you should do paired end 75 for RNA-seq. Yeah? So then, and then, for example, for whole exome, you would do 2 times 150. That's 30 hours. Yeah? A little bit more than 1 day. So
it depends on program.
Yes, on the.
Ну, то есть, ну, грубо говоря, там есть там конкретные, там, грубо говоря, программы, то есть мы ничего там не меняем и...
How to choose which program?
Мы не меняем ничего программы.
Нет, вы не меняете ничего.
Да.
Программа фиксирована.
Да, да, да.
Well, I mean, it depends what you want to do. So, if you want to do, for example, whole exome, you choose this 2 times 150, parents 150.
Давайте, да. Я тут имела в виду, что когда мы для капиллярных секвенаторов, там тоже есть...
Не, это как мы сидим.
Ну,
это
мы
выставляете
не меняем, то есть вообще не трогаем.
Просто циклов выставляете.
No, I'm not absolutely sure about the question. So, of course, you can, if you have, for example, a kit with 2 times 150 or 300 cycles, yeah, you don't have to do 300 cycles. You can do only half of it, yeah. That's possible. Then, of course, you would kind of waste the reagents, but it's possible. So, you know, it's not. Well, for some applications, we don't always have. We try to make kits that more or less fit different applications, but sometimes we don't have it. Yeah. So, for example, if you would do small RNA, yes, microRNA, you know they are short. They're really short. Yeah. So, not more than but we don't have 25 cycles. Yeah. And so then you would maybe use the 75 cycle kit, but you do not 25. I would recommend to do maybe 36, or let's say at least it should be at least, so the minimum you should do is 26, yeah, because it needs 25 cycles to do the matrix. So I would do maybe at least 30 cycles, yeah. But more is not necessary. It's maybe even not so good, because then you sequence the adapter and it's not making it more pretty, yeah. So the data.
А таргетные панели тоже подбираются под этот или под сети, не наоборот?
Еще раз.
Когда мы заказываем, у нас есть, допустим, там 200 праймеров, 200 генов, которые мы хотим посмотреть, как бы, экзом. То есть, соответственно, мы отправляем в Иллюмину, как это сегодня называется? Вот, соответственно, то есть там для маркетинга, да, то есть они подгоняются под хит или они изначально приходят с программой? Ну, в смысле, под какую-то...
Я кажется, что понял, что...
Да, я вообще сформулировать, называется, пытаюсь.
The main question is, for example, if they perform project in design studio, for example, enrichment, would it be suitable? Would it be suitable for? How can they detect which cartridge should they use or which machine should they use? Of course, it strongly depends on the size and the number of samples, the size of cumulative length of your region of interest, and number of samples. And you can calculate the coverage. It's pretty easy. There are some coverage calculators.
So if you have doubts there, just ask us, yeah, for case by case, and after some time, I think you will have some experience to make the decision. But you can always ask us, yeah. So ask the colleagues from ILS, or you can, if they're maybe not available, you can send email to tech support. So or call them. So in general, if you do enrichment or exome, it's also a type of enrichment. It's always 2 times 150 cycles, yeah, always. If you work with amplicons, it's usually, it can be smaller. It depends on the size of amplicon. So for RNA, it's what we as a standard recommend is paired and 75 cycle. In some cases, it's even enough to do single with 75 cycle. Yeah. So these are just some examples. Okay. So the flow cell, you have seen it. It is shipped dry. This is also different to Nextseq. Nextseq always comes in a buffer, and you know it must not be frozen. This is for both, yeah. And this comes dry. It also has a barcode. You can, when you touch it, just touch the plastic frame. Yeah, it's similar like an iPhone. It has 2 pairs of lanes. So we call it pair A, and this is lane 1 and 3, and pair B is lane 2 and 4. And the reason why we do this is because lane 1 and 3 is filled and also imaged from top to bottom, so in this direction, and at the same time lane 2 and 4 are filled from bottom to top in the other way. This is important also for the engineer and application specialist to know, because sometimes if there is something wrong, you can see which lanes are affected. Yeah? So this can be some indication. So this is the format of the flow cell. So similar as with Nextseq, you have the individual lanes subdivided in, we call it swath. Yeah? So this is a small stripe part of the lane. And then again, vertically, we subdivide it into tiles. And I said before that we have we have 6 cameras, and each camera is covering one section. Yeah, so this is, for example, I don't know if it's camera 1, but it's one of the 6 cameras. Here is another one, here, and here. So 6 parts, 6 cameras. And this is then each tile, each image, which becomes a data file, has a number, and this nomenclature is structured in this way. Yeah? So the first number is the lane. So if it's 2, it would be this lane. Then it's top, bottom. So like with Nextseq, we have top and bottom surface of the lane. So if it's 1, it is top. Then it is the second swath. Yeah. So this is swath 2 in the middle. And then it is section 1. So it's this camera. Yeah, here it's numbered. Camera 1. And it is tile number 4 inside the section. Yeah, so here you see tile number 4. Then the cartridge in more detail. Yeah, similar to Nextseq, you use it only one time. Here the 10 is for the library, so always orange. Yeah. So even after some vodka, you will find it. It's really not even permitted. Then number 7, 8, and 9. This is for custom primers. Normally you don't need it. Only if you have a custom recipe with your own indices, then you would need it. Then 6 is for the denaturing. This is formamide. And some customers requested, for example, especially in Germany, you know, we are crazy about environment, greens. So some customers didn't like that the formamide is part of the whole assembly. And they asked, is it not possible to separate it so that they can put it in a different special base? Yeah, so because formamide is hazardous. All the other reagents are pretty harmless. So now we did this in this cartridge. After using it, you can separate this reaction number 6, which is the formamide, and you can put it in a separate container. Don't drink it. Yeah. And so these numbers here in blue, they are for the wash. They are used for the wash. So they don't really contain any reagents. This is the buffer cartridge that comes also with the kit. So you have 3 different buffers: sequencing buffer, a wash solution, and incorporation buffer. And the wash solution is in the middle. good to know because you also have a wash cartridge and there you fill only the middle position. And yeah, this is how you load it into the system. So this here is the waste. Yeah, we call it spent reagent tray. You know, Americans, they like to carefully select the language. So you're not allowed to use any bad words, and waste is very negative, so don't speak about waste. So it's a spent reagent. Yeah, this is... yeah. Also in America you don't say Christmas, you say holiday. So the Christmas tree is the holiday tree. So some years ago I sent an email, Merry Christmas, to colleagues in the States, and I got one email back, please don't say Christmas, it can hurt somebody who is non-Christian. And you know, I have friends who are non-Christian and they say they don't care. They say Christmas, yes, even if they don't believe in it. So anyway, so this is the spent reagent tray. And the software, so MySeq control software is MCS and Nextseq control software is NCS. So yeah, this is good to remember if you talk to tech support. Right. This is what it looks like. It has only 3, so it's fairly clear structure, yeah, sequence, manage instrument, perform wash. Data analysis, so the primary analysis, I mean, extracting intensity from images and then doing the base calling. This happens directly on the machine, and this is done by NCS and RTA. So this is directly automatic. Yeah. Then the output data. So the raw output is BCL format. So the standard format for Illumina system, it is Illumina format. Yeah. So it's still not the standard if you compare it with other platforms. The general standard is usually FastQ. If you want FastQ, and normally this is what you want, you need to convert BCL into FastQ. This can be done either through base space in the cloud, number one, or through base space on-site, what you have bought and what unfortunately still is not working, but we will do this in January. And number 3 is you can also save the BCL files on a server, and then you use a software that we can give you, or you can download it. It's called BCL to FastQ Converter version 2, and it's fairly simple to operate, and it converts the BCL into FastQ. You need a Linux system for this.
Red Hat or CentOS?
Red Hat, yes.
Red Hat, I think the Red Hat or CentOS.
Yes, yes. I think most people use the Red Hat. Yeah, I think both is possible. Yes. So this is different to MySeq. Yeah, with MySeq you get immediately the FastQ.
You have no program for MySeq, for Nextseq. У нас вообще нет программ нормальной для обработки, когда их купят неизвестно.
And they haven't program for performing biosystematic results of MySeq run. They
Надеюсь, что рано или поздно ее купят.
They hope that they buy maybe CLC Bio
Okay, okay, yes.
But now they have.
Okay.
And now they cannot work with Unix programs for
Ну, у нас
bioinformatics.
Сергей, как бы у нас Сергей учится.
Sergey is learning now.
Okay.
Такой, что как ты ездишь на занятия.
Can be
Biostatistics, but
they can use the DSO as a very strong Linux machine in order to do everything there, because the Linux
no. So the DSO has pre-installed software, so there you cannot install other software.
cannot.
No, you should not. You can.
Okay.
Then it can really broken the system. Yeah, so you should not install.
на сервер не установить ничего.
Да, следующий звонить. Okay.
So
That's
of
a
course
protection.
yes, but it's yeah. So the base space on site it has now the software to do whole genome sequencing and to do exome sequencing and RNA-seq.
Mm-hmm.
So there you have already the software. For other applications, at the moment, with base space on site, you get the FASTQ files, so the standard format that you can import in other software packages. But then you need still another software.
Can they analyze the data from the Nextseq as well on the DSO? By somehow loading it on, or I don't know.
As far as our plan is, to be honest, I'm not absolutely sure. My information is that at the moment not yet. So our plan is to make it universal for all systems, the DSO, but I think it's not yet ready for this. So at the moment it's only for the Nextseq.
Короче, в январе будет программа на сервере,
Короче,
для
да.
все анализировать.
But for the yes.
Для Nextseq.
Yes. But of course, for example, for bacteria, you need other software, and this is at the moment not yet on the base space on site. Yeah. So it's on base space cloud, but not yet on base space.
So you can always use base space cloud.
Короче, надо выбивать все эти программы изначально нормально для обработки.
А чем плохо делать?
So, but I would recommend you, if you learn this, to really. So now, when we start the experiment today, we will use the cloud. And cloud is free of charge. I know for you it's maybe not possible to use it all the time, but at least you can try it. You can learn how to work with the software in the cloud. Yeah, so it's free, and really use it. You can also get, if you need sample data to play, we can give it to you. So really use it. It's, and there you have already all the different applications, and yeah, it's completely free to use, and it's easy. You don't need Linux or something like this. So it's yeah.
But Sensibilio gives us better results.
No, it depends what you want to do, but actually with base space you can get the same. You can get the same. Of course, yeah. Maybe each software has some advantage and some disadvantages. So maybe for some things Bio is better. For other things, you know, in base space you have many different softwares. It's not only one. It's a platform. So.
Ну я смотрел там, да.
But really start to use it because if you learn to work with the cloud, it is exactly the same principle for the base space on-site. Yeah? So the structure is the same. And the base space is really important for the Nextseq, because we really we developed it together. Yeah? So the idea is to use base space for the Nextseq. Of course, if you cannot, so our main idea was to use the cloud, because we feel that in future the biggest part of software, of data analysis, will happen in the cloud. This is our feeling, how we see the market developing. In America, it's already quite far in this direction. Now also in Europe and Asia, they go, but of course, it's not everywhere possible.
Forensics.
Yes. So this is why we have developed this on-site solution. But as a consequence, our standard way to start an experiment is also going through base space. So, you know, with Nextseq you use the experiment manager to make the sample sheet. For Nextseq, you can also do this. You can use experiment manager, but this is not the standard. The standard for Nextseq is to use base space. And we call it the prep tab. Yeah, so it's one tab in base space to plan your experiment, and it has the same function as experiment manager.
If they have problems with internet connection.
Yes, so if you have a problem with internet, so
is there any kind of base space broker or something like this which will accumulate the data and then transfer it?
Yes, yes. So exactly. So if the connection is stopped during the experiment, it will be saved temporarily on the hard disk. So the hard disk always has to be empty when you start the experiment, because really the amount of data is much bigger than with Nextseq. So it really has to be empty. Remember this before you start an experiment. Then it will temporarily save it on the hard disk, and then it will continuously try to upload it to the cloud. I think it tries it at least 2 days. Yeah? So if it's longer broken, then maybe you have to manually transfer it later. Yeah, but usually it should not be broken for more than 2 days. Okay. But you need to make the decision before you start the experiment. So when you start the experiment, you need to decide, do you want to use base space in cloud, or base space on-site, or some local server. Okay. So just some examples. Yeah. So for example, you do a very simple gene expression profiling experiment. You do 2 times 75 base pairs, or maybe only single reads. It's also possible 75 base pair. And then you use a high output flow cell, and you can pool up to 40 samples. Yeah. So actually, I mean 40 is a bad number. In reality, it would be maybe 36. Yeah. And then mRNA-seq, it's basically the same. Yeah, it's gene expression, but this is meant if you are, for example, looking at splice variants and things like this. Then you need a little bit better resolution, and you need more reads. Yeah? Instead of 10 million per sample, you would need maybe something like 40 million, and then you just pool less samples. Then if you do enrichment panel with 12 megabases, sorry. So this is already quite a big panel. Yeah. So this is something like TrueSite 1, yeah, the clinical exome. Then in mid output it would be 20 samples, high output it would be of course more. Something like 3 times, maybe 60 samples. Whole exome, here something between 3 on mid output or 9 samples on high output, and whole genome 1 sample in high output. Yes, so it's just an overview of the workflow. So this here is analyze and share the data. This can happen in the cloud. So the other reason why we think the cloud is good, because you can share data very easily. So if you have collaboration with institutes in Moscow, they can just, you give them permission, they download it immediately, or they can even analyze it in a different way. So you don't have to send a hard disk or do some complicated transfer. Попробуйте.
В плане промывки, Nextseq надо промывать водой после и перед каждым запуском. Есть ли в этом плане необходимость для
They ask about the washing step. It's required to wash the instrument with water before and after each run.
You should wash it before each run. And we have a wash protocol, I will show it to you.
Перед каждым запуском нужно использовать
Я поняла,
промывки.
просто в Nextseq мы ставим трубку с водой. Здесь картридж с буферами. То есть мы промываем Nextseq с водой или с
In the Nextseq they just use a bottle with water for washing, and here you have the special cartridge. So for the washing protocol you use what in Nextseq?
Yes, so for washing normally you use 0.05% twin 20 in the, so it's the middle section of this wash cartridge.
So they use the wash cartridge for the washing. That was the question, I think.
I will show you everything.
Okay. So and then they exchange the cartridge for the sequencing. So first they do the washing with the washing cartridge.
So you do an experiment. Before you start the experiment, so when you set up the reagent cartridge, in one position, I think it's 18 or 28, you fill the hypochlorite, sodium hypochlorite solution. And this solution is used directly after the experiment for the self-cleaning automatically. You don't have to do anything, it's happening automatically after the experiment. And then you leave everything in the machine. Next time, before you start an experiment, you take the used cartridge out, you put in a wash cartridge, and then you wash with twin solution.
А вот этот wash cartridge, мы там уже что-то есть? Или вы в него наливаете?
Нет, вы в него наливаете.
Наливаете.
После этого шкафу пустой.
Ну, то есть вот в него...
I will show it to you.
Просто в Nextseq же там картридж и бутылка.
А это Nextseq.
Да, то есть, ну, вот я...
I will show you.
При большом перерыве между запусками, то есть промывка тоже производится клином. Потому что дело в том, что у нас была проблема с Nextseq, насколько я помню, с пузырями.
So the question is if there's a long time between two runs. I think that's not just standing around for a long time without runs. They had troubles with the Nextseq because there were some bubbles during cleaning. Still they use twin in such cases?
Well, I mean, this is the official information that I have. So I think actually also the concentration of twin is different between Nextseq and Nextseq. So be careful there. I heard about this problem with bubbles. but yes, officially, so we recommend to use the clean solution.
Во всех случаях.
And also, since the tubing is less tubing in the Nextseq, maybe you don't have this problem with onyx. So okay. In general, you should do this wash if you have not used the system in 2 weeks. If it is shorter than 2 weeks, then you don't have to do a wash.
Ну, я думаю, мы вряд ли будем запускать его каждый день. Сильно по-другому.
Ну, сейчас
Окей.
машина успеет каждый день.
А зато до этого последний раз зимой, сначала в январе, а потом летом.
Ну,
Это сейчас 4 раза за 2 недели.
So this was the first presentation, but I